Section 9.7, the title of the section is the law of sines and law of cosines, which we don't know what those are yet. Okay, but you will by the end of the section. So the section really has three parts. First, we're going to find the areas of triangles, which we've already done that some, but we're going to look at a different way of finding the area. We're going to learn about something called the law of sines and see how that can be helpful in solving triangles, and then something called the law of cosines. Okay. So first, up until this point, our sine, cosine, and tangent have been thought of the ratio of the opposite sides. So we've only been finding the sine, cosine, and tangent of acute angles. Because in a right triangle, you have a right angle and two acute angles. Okay? But you can actually find the sine, cosine, and tangent of an obtuse angle. So yes, you can. At this point in our trig knowledge, we're mainly going to be using a calculator for that. Okay, so basically, we are going to use a calculator. Okay, if you want to know more about the sine, cosine, and tangent of obtuse angles, we spend over half the year in pre-calc on that topic. So we are going to use a calculator. Okay, so first things first, we're just going to do some approximating of obtuse angles. So we're going to find the tangent of 92 degrees. Again, make sure you are in degree mode, under mode here. Second quit to get out of there. And we'll just go the tangent of 92. And we get negative. If you notice, we end up getting negative numbers here. Again, that doesn't make sense with that whole ratio idea, but we'll explain that in more detail again in pre-calc. So the tangent of 92 is approximately, it says to 4 decimal places, so negative 28.636, and then that's a 2 behind, that's a 5, so it's going to go to a 3. Negative 28.6363. Okay. So now let's find the sine of 175 degrees, the sine of 175. Is approximately 0.0872 if we go to 4 decimal places, 1, 2, 3, 4, 1 behind it's a 5. And then the cosine of 149 degrees, we get negative, is approximately negative 857, 1 behind it's a 6, so that would go to 2. Okay, so really this is just practicing, can you punch things into your calculator, and do you know how to approximate? Okay, can we round to appropriate place? Okay, so finding the area of a triangle. Okay, if we have a right triangle, the area is pretty straightforward. Area equals 1/2 the base. I'm just going to write the word base. 1/2 times the base times the height. We normally write it as 1/2 BH. But the one difficult thing is that height needs to be that perpendicular height here. So in this case, my base would be this distance right there. And my height would be this distance right here because it's that straight perpendicular. So in a 90, in a right triangle, 1/2 base times height works really well. Okay, but not all triangles are right triangles. What if we have a triangle like this? Okay, we can still use this same idea. Okay, and we can still use this B for my base. Okay, but my height here gets a little more complicated because the height is this perpendicular. So there's my height. Right there is my H, my height. Okay. So to actually find that height, we can use our trig. So if you notice, this is a 90-degree angle right here. So what I've created right here from A to B to, let's call this point right here D. A, B, D, what I've created is a 90-degree angle, a right angle. And if I knew what angle A was, okay, and here if we knew what C was, I could find this height. So let's go ahead and let's set up a trig ratio using this angle A and side C to find that height. So if this is my angle that I know, this here would be the opposite side. This one again is my hypotenuse, because it's across from my 90. So opposite hypotenuse, if we use our SOHCAHTOA that we know so well now, opposite hypotenuse is sine. So we would know that the sine of angle A would equal opposite h over hypotenuse C, h over C. But again, our whole goal is to find this height. Our goal is to find the height. Okay, that's our goal, find the height. So to solve this, put that over 1, we'll go means extreme. So we'd have C times the sine of A equals the height h. So there, we have the height is equal to this guy right here. The height, switch colors, is equal to this guy right here. Okay, so since this is the height right here, I'm going to replace that with my height over here. So again, my base of this triangle is B. So my equation now comes, my area is equal to 1/2. The base is B, but now my height is C times the sine of angle A. Okay, so now what we've done is we've come up with a new equation for the area. Area is equal to 1/2 B times C times the sine of the angle in between. Hey, so we could have used this angle over here, used angle C instead, and then it would have had side A instead. Okay, so it would have got us a different version. Or we could turn this completely, have our height come this way, and use angle B. So really, it depends on which two sides you know. So it's 1/2 times side B times side C times the angle in between B and C. And so that leads us into, we now have 3 new equations for area. Okay, 1/2, again, this is 1/2 times B times C. Again, there's times here, times the sine of angle A. If you notice that side B, side C, angle A, this is the angle that's not with one of these sides. Same here, A times C times the sine of B. So we have ABC in here, and then here we have an ABC in here, the sine of B, sine of C. So what this allows us to do is it allows us to find the area of a triangle that's not a right triangle, that we might not actually know the height of it. Okay. For example here. Okay. So find the area of the triangle. So I know 2 sides, and I know the angle in between. So I'm going to go ahead and I'm going to maybe relabel these. If this was side lowercase a, this was side lowercase b, then that tells me this would be angle uppercase C. So the area, because again, it's the 2 sides, and the angle in between them that you have to know to use this formula. So it's the 2 sides and the area in between them. So area equals 1/2. It would be A times B times the sine of angle C. So it would be 1/2 times side A, which is 12, times side B, which is 15, times the sine of 110 degrees. Okay. And actually what you can do is you can do this. We're going to get an approximately because the sine of 110 isn't a nice even number. But now I can actually just type this whole thing in my calculator. See my calculator, do I have enough light? Okay, so I'll just type in 1/2 times 12 times 15 times the sine of 110. Do it all in a row. We get 84.57, round our answer to the nearest tenth. Tenth is 1 decimal place, there's a 7 behind it, so it'd be 84.6. Sorry, fuzzy. 84.6. My units here would be square units because it's area. So that is now the area of this triangle. Okay. 84.6 square units. Okay, so this is one way of finding the area when you know. Okay, let's come back to area of a triangle. Here's the things you must know or be able to find. Know 2 sides and the angle and the what we call included angle. Okay, so what that looks like in a picture, if I have a random triangle, to use this formula, we need to know two sides. We would need to know this side and this side. So we would need to know, say, I don't know, this one, and this angle in between. So we would have to know these two sides, and let's grab a different color. Let's go green. And this angle in between. Okay, to be able to use this equation, to be able to use this formula for area. Okay, so there's our first part, area. Okay, stay tuned for the next.